Hello and welcome again to the first part of our tutorial, which is going to be, I should say, the data knowledge and data exploration and knowledge discovery about the Alzheimer datasets that we just uploaded on the previous tutorials from the resource section. Now, because the things that we are just going to follow, it's the thing that either you know that before, or that these are the knowledge and the contents that you have learned that from the other three courses, which they were the prerequisites for this capstone project. Then in order to save some time, I have written these codes here just to execute them, to show what are we looking for instead of explaining how to write the codes. But at the end of the tutorial, when you do the tutorial, you can access to the code which has been written in the R, and instead you can just follow the codes as I also move along to just execute it line by line. Okay, from the previous tutorial, we were able to upload, I should say, the datasets that we had. It was a longitudinal datasets, and as I said, either you can just upload that from the resource section at the previous tutorial, or you can just get it from the Oasis the websites, after having an account with them, or either you can just get that datasets from the Kaggle website if you search by the Alzheimer then. Okay. Now, when you just set the directory in the folder that you have, I'm just going to execute the line by pressing Ctrl Enter, and you see that the data is created, which consists of 373 observations of 15 variables. For the reasons that you're just going to see, I should say, from the next tutorials, I'm just going to take subject ID and MRI ID, I should say, put them aside, because in the future tutorials you see that I'm just going to work with them. Now I'm just going to set them aside, create two objects, subject ID and MRI ID, which are essentially two features of my datasets. The first thing which I'm just going to do, I'm just going to go ahead, just see the structure of the data. You see that the features that we have in our data frame, we have the subject ID. Each subject which goes under, I should say, the MRI, you are given an ID. And we have the MRI ID, the number of the experiments which is done on them based on the MRI session that they are booked. They have received an ID. I just put them aside for future, I should say, tutorials. We also have the group, which it shows it's a character. It consists of, I should say, three different, I should say, category. Either that person is demented, which it means that he has been identified as a person who has Alzheimer, or he is non-demented, or he is converted. We are just going to talk about that more. And also we have the number of the visits, which is that integer. For example, one time they have been booked for the MRI, or 2 times or 3 times. And also the MRI delay time. We're just going to talk about that later. And also we have the M and F, which is essentially a gender. M signifies the male, F signifies the female. And also we have the hand. If that person is right-handed, which is denoted by the R, or if he is left-handed, which is denoted by the L. Also, we have the age of the, I should say, of the patients, or the, I should say, the sample, which is an integer. We have the age, for example, 87, 75, which, as I said, it ranges from 60 to 90, and we are just going to see that more. We have another feature, which this is called education. It's an integer, the number of the years that that person has spent at the school. For example, it can be 14 years, which is going to be denoted as that person has an, I should say, 14 years at school, or it has a 12, which means that he has a high school diploma. We have SES, which is an integer, which stands for social economic status. You see that also we have some kind of NA, which is going to also denote that it's going to be missing values in that column, in that features. We have also MMSE, which is a kind of a feature, I should say, in an MRI. We're going to talk about that more, I should say, when we just, we're going to talk about that. Also, in the code which you see, I have denoted, for example, what these things stand for. MMSE is a kind of a mini-mental state examination, which is a kind of a cognitive test in order to give a score to see that if that person is suffering from some kind of a dementia. Also, we have another feature, which is CDR. CDR stands for Clinical Dementia Rating, which we're going to work with that features more when we're just going to work in order to just give different levels in our Bayesian analysis. We have, I should say, ETIV, which is essentially, so that's an integer number, which is the estimated total intracranial volume of the brain. And also, we have NWBV, which stands for the normalized whole brain volume. That's the feature that we're just going to work with that in our Bayesian analysis. And also we have ASF, which is ASF is essentially, it's a kind of a Atlas scaling factor. And these are the features of our data sets. We're not going to talk about exactly what they are. I'm just going to put in the resource section of this tutorial an article which explains in details what is the clinical significance of each features in our data sets. But we are just going to move ahead and just with the features that we're just going to work with that. We explain more about that. And also, we have another command here that needs to be executed. We have the summary of the data. You see that when you run the summary section, you see that, for example, all the things that you had in your data sets. For example, the subject ID, we had 373 observations. Also, the other thing which is going to be very important, you see that, for example, with the age, you see that the minimum age is going to be 60 and the maximum age of the patients or the people which they have just gone to the clinics for that study is going to be 98. Then our data sets includes the people aged from 60 to 98 years old. And also, the other thing which is going to be relevant for our study is going to be the level of the educations. In our the group, we have the people who have only have the education which is lasted only for 6 years, and also we have the people who have been at the school with the 23 years and they have done pretty much advanced level of the education then. And also for the socioeconomic statutes, we have, I should say, the thing which is going to be relevant for at this part is that you see that we have 19 missing values. And also for the MMSE mini mental state examination, you see that we have 2 missing values. Also we have the CDR, the clinical, I should say, dementia rating, and also ETIV, and also normalized whole brain volume, which means that it can ranges from, I should say, 0.64, I should say, cubic centimeter to, I should say, to 0.83, which is essentially they are normalized, and that's why you see that they are essentially less than 1, and that's the thing that we're just going to use for our model analysis. And also we have Atlas scaling factor, and in case if you are interested to know what is that, you can refer to, I should say, the source which I have put in the resource section of the same tutorial. However, look at that, we're just going to work with the normalized whole brain volume, which this is normalized, and that's why you see that it's less than 1. Okay, and now I'm just going to just move on for, I should say, for the data exploration analysis, and do some kind of, I should say, interesting plots in order to visualize the things that we have to do. First of all, we need to have the access to the car library. And also when you have the access, you can just, I should say, the box plot the normalized whole brain volume with respect to the age. Because if you remember from the introduction of these tutorials, the plan that we have in your mind is that we are just going to have a model which predicts and models essentially the brain volume changes with respect to the time and age, and that's why the box plot is denoted as a formula like that. And also I'm just going to execute the line to see that how the box plot should look like. I'm just going to zoom on the data. You see that the normalized whole brain volume with respect to the age, how it changes. You see that from the average, you see that how the things changes. as you see that as the people are just growing older when they just go to the age of 98, you see that explicitly that the average, I should say, of the brain volume is reduced significantly, and when they are at the age of 98, you see that the brain volume, the whole brain volume, it's going to be significantly lower when they are, let's say, at the age of 60. And that's the thing that is going to be very interesting, and that's what we see. However, I'm just going to attract your attention to the fact that for this analysis, we do not include any levels and any variations. If that person is demented, I mean, if he or she has an Alzheimer, or if he is male or female, what is the level of the education and what is the level of the social economic status on our model there. That's a simple level model which it shows that how the age changes with respect, how the brain volume changes with respect to the age by using a box plot. And also, I have another scatter plot in order to show that to you. And that's the thing that we are just going to just work on the future tutorials to see that how we can just plot it. And you see that for the scatter plot, I have the normalized whole brain volume. And with respect to the age on the data, and I'm just going to execute the line by pressing Control Enter, and you will see that. If I'm just going to zoom it, you will see that the data is scattered, something like that. You see that. On the x-axis, we have the distribution of the age from 60 all the way going after 90. We know that we should have 98. And also on the y-axis, we have normalized whole brain volume. And each dot that you see here, it's going to be essentially the normalized whole brain volume of one of the people who has been referred to the clinic for the study. Then you should expect to have 373 points in our plane. And also you see that the box plot for each, I should say, for each features there. For example, for the age, the box plot, which it shows that the average. And also the normalized whole brain, it has been, I should say, denoted along each coordinate there. Then now, and you see that also, you see that some kind of a non-Bayesian fitted model into our data sets. You see that the non-dashed, I should say, the plot, the straight line, it shows a kind of a modeling, the regression models of these simple observations. And also, before we just move on to show you some variations, and essentially these are the things that I just wanted to show that to you in our section for the knowledge discovery, to see that how we just, what kind of features do we have, and particularly bring your attention to the fact that we have two features which is going to be very interesting for us. And as you saw, one of them is going to be the normalized whole brain volume, and also the age. These are, one of them is going to be the independent variable, which is going to be our response variable, which is going to be the normalized whole brain volume, and also the age, which is going to be the dependent variable then. And as I'm just going to emphasize again once more, is that in our crude analysis that we have done so far, I didn't incorporate any other features such as age, gender, SES, and the education, or for example, the group level and the variation between them into our model. That's the basic single level model that we just wanted to see what are the features available in our datasets. When we come back at the next tutorial, we are going to look into different, I should say, features which they cause, and I should say a kind of a variation that may changes the result of the brain atrophy with respect to the age. Okay, I can't wait to see you back at the next tutorial. Then we talk about some interesting features of the variations between groups. See you later.